Now we're going to talk about how to write the equation of a hyperbola. There are 4 things that we need to know about the hyperbola before we can finish writing the equation. The first thing that we need to know is the center. The center tells us the h, k portion of our equation. The next 2 things that we need to know are a squared and b squared. The last thing we need to know is whether or not the hyperbola is horizontal or vertical. If the hyperbola is horizontal, we know that the x term will go first, and if it is vertical, we know that the y term will go first. So let's take a look at the first problem. In number 1, we know that the hyperbola has foci at -4, 0, and 4, 0, and vertices at -3, 0, and 3, 0. Just like the ellipses, I suggest drawing a picture first to give you an idea about what is going on with your hyperbola. It makes writing the equation much easier. So, let's draw our foci on at 4, 0, and -4, 0. I'm going to label them with little f's so we remember that they are foci. Then we have vertices at 3, 0, and -3, 0. Write little v's by those guys. So based on this picture, we know a lot about our hyperbola. We know that our hyperbola is horizontal, so the x will go first. And we know that the center is at 0, 0 because it has to be in the middle of those points. So since our center is 0, 0 and the x has to go first, we know that our equation is going to look like this: x squared minus y squared, and that'll be set equal to 1. We still need to figure out our a squared term and our b squared term, but this picture actually shows us our a, which is 3. That is the distance between the center and a vertex. So we can put a 9 underneath our x squared term. Then we can use the equation c squared equals a squared plus b squared to help us find our missing term. So from our picture, we can see that our c value is 4, because that is the distance between the center and the focus. So we can plug a 16 in for c squared, plug a 9 in for a squared, and because of this, we can find that b squared equals 7. So we could put a 7 underneath our y squared term, and we have our equation for our hyperbola. The next problem that we're going to look at gives us a hyperbola with vertices at -2, 1 and 2, 1, and it tells us that our hyperbola passes through the point 5, 4. So let's put what we know so far on a graph and just draw a little picture so we can see what's going on. So we can put our points at 2, 1 and -2, 1. And this tells us that our center must be at the point 0, 1. From this picture, we can also tell that this is a horizontal hyperbola, so the x squared term will go first. And this time, our center is at 0, 1, so we're going to need to write a y minus 1 squared up at the top. We also know our a value is 2, so we can put a 4 underneath our x squared term. And now the only term that we need to still find is b squared. So this time we can't use the focus equation to help us because we don't know what our foci are, but we do know that our hyperbola passes through the point 5, 4. So what we can do is we can plug the 5 in for x and the 4 in for y and solve for b. So let's do that. So we have 5 squared over 4 minus 4 minus 1 squared over b squared equals 1. So that gives us, scoot this over a little bit. So it gives us that 25 over 4 minus 4 minus 1 is 3, so 3 squared is 9. 9 over b squared equals 1. Subtract 25 over 4 from both sides, so that'll give us negative 9 over b squared equals, this is really a 4 over 4, so that'll be a negative 21 over 4. Do a little cross multiplying, so we'll get negative 21 b squared equals negative 36. And when we divide by negative 21, we find that b squared, once you reduce the fraction, is going to be 9/7. So, for our final equation, we want to take that 9/7 and I'm going to have to cheat a little bit and write down here. Our final equation is going to be x squared over 4 minus y minus 1 squared over 9/7 equals 1. And you can leave 9/7 in the denominator since that is the standard form of a hyperbola. Okay, now we're going to write the equation of a hyperbola given the vertices and the asymptotes that go through the hyperbola. So let's start out by drawing a quick picture. So I have vertices at 3, 0, and 3, negative 6. Okay, so 3, 0, and 3, negative 6. So we can already tell that this is going to be a vertical hyperbola. And from these vertices, I can tell that my center is going to be at 3, negative 3, since that is the midpoint. So, since this is a vertical hyperbola, we know that the y is going to go first. So we're going to have a y plus 3, since negative 3 is our k value, minus x minus 3 equals 1. Oops, squared. Okay, we know that our a value is 3, since the center is 3 away from our vertice. So remember, in hyperbolas, the a value always goes first, so we're going to put a 9 underneath our y squared term. And of course, that pesky b squared term is what we need to figure out. So what we can use is the information from the asymptotes to figure out what b must equal. Since the slope of both of our asymptotes are 1 and negative 1, and we know that our a value is 3, we know that our b value must also be 3. For the slope to equal 1, our asymptotes must go up 3 and over 3, or up a and over b. So, since we know that our b is 3, we can write a 9 underneath our x squared term.